Imagine this. Imagine you're standing on top of a mountain. The air is cold. Clouds float below your feet. You look around and think, this mountain has probably been here forever. It feels permanent, unchanging, ancient. But what if I told you, this very mountain is still changing? Not every day in a way we can notice, but every single second, our planet is changing. Mountains continue to rise. Rivers slowly carve valleys. Coastlines change shape. Volcanoes create new land. Earthquakes shift the ground beneath our feet. The Earth is not just a giant rock floating through space. It is alive with movement. It is constantly reshaping itself. And that is exactly what this chapter is about. A planet that never sleeps. When we look at the Earth from space, it appears calm and peaceful. A beautiful blue planet, but beneath that peaceful surface, an incredible process is taking place. Deep inside the Earth, rocks are moving. Heat is flowing. Gigantic plates are slowly traveling. These movements are incredibly slow, usually only a few centimeters each year, about as fast as your fingernails grow. Because the movement is so slow, we never notice it during our lifetime, but over millions of years, those tiny movements completely change the face of our planet. Huge mountains appear, oceans grow wider, new islands are formed, old land disappears beneath the sea. Slowly, the Earth keeps rebuilding itself. Look around you. Mountains, valleys, plateaus, plains, deserts, beaches, cliffs, waterfalls. None of these landforms appeared by accident. They were shaped by powerful natural forces acting over millions of years. A landform is simply a natural feature found on the Earth's surface. Mountains, valleys, plateaus, plains, deserts, and coastal features are all examples of landforms. Some landforms are created by powerful forces acting deep inside the Earth. Others are slowly shaped by wind, water, ice, and weather over long periods of time. Understanding how these landforms are formed helps us understand why different places on Earth look so different. For a very long time, people believed that continents never moved. They thought the Earth had always looked exactly the same. Then, scientists made an amazing discovery. The Earth's outer layer is not one giant solid shell. Instead, it is broken into several enormous pieces. These giant pieces are called tectonic plates. Think about a cracked eggshell. Although all the pieces together form one shell, each piece is separate. Our planet works in a similar way. The Earth's surface is divided into many large and small tectonic plates. These plates are always moving, very slowly, but continuously. This idea is called the theory of plate tectonics. It was proposed by W.J. Morgan, and it explains how the movement of tectonic plates creates mountains, volcanoes, earthquakes, and many other physical features of our planet. Let's take an imaginary journey. Suppose we could drill a giant tunnel straight through the Earth. What would we find? The Earth is made up of three main layers: the crust, the mantle, and the core. Let's explore each one. The crust. The crust is the outermost layer of the Earth. It is the part where all life exists. Everything we see, mountains, cities, forests, roads, rivers, and oceans, lies on the crust. Compared to the size of the Earth, the crust is surprisingly thin. Under continents, it is about 30 to 40 kilometers thick. Under oceans, it is even thinner, only about 5 to 7 kilometers thick. Beneath the crust lies the mantle. The mantle is extremely thick. It is also very hot. Although much of it is solid, some parts behave like a very thick paste because of the enormous heat. This slow-moving material plays one of the most important roles in shaping our planet. Without the mantle, tectonic plates would never move. The core. At the very center of the Earth lies the core. The core is divided into two parts. The outer core is made mostly of liquid iron and nickel. The inner core is solid because of the enormous pressure. Although temperatures inside the core are hotter than the surface of the sun, the immense pressure keeps the inner core solid. The heat produced here powers many of the processes taking place inside the Earth. And to understand how that heat moves entire continents, we first need to explore two special layers. The first is the lithosphere. The lithosphere is made up of the Earth's crust, together with the uppermost part of the mantle. This is the rigid outer layer that is broken into tectonic plates. Below it lies another layer called the asthenosphere. Unlike the lithosphere, the asthenosphere is not completely solid, it is semi-molten. That means it is hot enough to flow, very slowly. The tectonic plates rest on top of this layer. Think about standing on an escalator in a shopping mall. Even if you don't take a single step, the escalator still carries you forward. The asthenosphere works in a similar way. As this slow-moving layer moves, the tectonic plates resting above it also move. The movement is incredibly slow, but over millions of years, it changes the entire planet. Now comes the biggest question. Why do these plates move at all? The answer lies deep inside the mantle. The Earth's core is extremely hot. This heat warms the material in the mantle. Hot material becomes lighter, so it slowly rises upward. As it cools, it becomes heavier and sinks back down again. This continuous circular movement is called a convection current. These convection currents push and pull the tectonic plates resting above them. As a result, the plates slowly move in different directions. The movement may be only a few centimeters every year, but over millions of years, it is powerful enough to create mountains, split continents, and trigger earthquakes and volcanoes. The Earth's surface is divided into many tectonic plates, but these plates do not move alone. Sooner or later, they meet other plates. The places where two plates meet are called plate boundaries. Almost every major earthquake, every volcano, and every great mountain range on Earth is connected to these boundaries. Scientists have identified three main types of plate boundaries. Each one tells a different story. Convergent boundary, when plates collide. Imagine two huge trucks driving towards each other. Neither one wants to stop. Eventually, they collide. Something very similar happens. Deep beneath the Earth's surface, at a convergent boundary, two tectonic plates move towards each other. But what happens next depends on the type of plates involved. When two continental plates collide, continental plates are thick and relatively light, so when two continental plates collide, neither plate easily sinks below the other. Instead, both plates crumple, fold, and are pushed upwards. Over millions of years, these folds become huge mountain ranges. One of the greatest examples is the Himalayas. Even today, the Indian plate continues pushing against the Eurasian plate. That means the Himalayas are still growing, although only by a few millimeters every year. Now imagine a different situation. One plate carries an ocean, the other carries a continent. Oceanic plates are thinner, but they are also denser, so when they collide with continental plates, the oceanic plate bends downward and sinks beneath the continental plate. This process is called subduction. As the sinking plate reaches deeper into the Earth, it becomes extremely hot. Some of it melts into magma. This magma slowly rises back towards the surface. Eventually, it erupts through volcanoes. That is why many volcanoes are found near convergent boundaries. These collisions also produce powerful earthquakes, but not every plate boundary is a collision. Sometimes, instead of moving towards each other, the plates begin moving apart, and that creates an entirely different kind of landscape. This is called a divergent boundary. Imagine pulling apart a piece of bread. As the two halves separate, a gap appears between them. Something very similar happens deep beneath the Earth's surface. Here, my two tectonic plates slowly move away from each other. As they separate, magma from deep inside the Earth rises through the gap. When the magma cools, it hardens into solid rock, forming brand new crust. In this way, the Earth is constantly creating new land. One famous example is the Mid-Atlantic Ridge. It is an enormous underwater mountain range formed as tectonic plates slowly move apart. Although we cannot easily see it because it lies beneath the Atlantic Ocean, it is one of the longest mountain ranges on Earth. But there is one more type of plate boundary. This time, the plates neither collide nor move apart. Instead, they slide past one another. This is called a transform boundary. Imagine placing two heavy books side by side. Push one forward, pull the other backward. Because of friction, they don't move smoothly. Instead, they suddenly jerk. Exactly the same thing happens beneath the Earth's surface. Here, two tectonic plates slide past one another. No new crust is formed, no crust is destroyed, but enormous pressure keeps building. When that pressure is suddenly released, the ground shakes violently. This is an earthquake. One famous example is the San Andreas Fault in the United States. It is one of the best-known transform boundaries in the world. Take a moment and think about everything we've learned so far: mountains, volcanoes, earthquakes, ocean basins, continents. At first, they may seem like completely different topics, but they all have one thing in common. They are all connected by the movement of tectonic plates. This is why the theory of plate tectonics is considered one of the most important ideas in Earth science. It explains why the Earth's surface is constantly changing. Instead of seeing mountains, volcanoes, and earthquakes as separate topics, we now understand they are all part of the same story. Now let's look at a world map. If you mark every major earthquake and every active volcano, you'll notice something interesting. They are not spread evenly across the Earth. Instead, many of them form a huge ring around the Pacific Ocean. This region is called the Ring of Fire. It stretches across countries such as Japan, Indonesia, the Philippines, New Zealand, the western coasts of North and South America, and many Pacific islands. It is called the Ring of Fire because it contains a very large number of active volcanoes and frequent earthquakes. Why? Because many tectonic plates meet around the Pacific Ocean. Their constant movement creates intense geological activity. That is why this region experiences more earthquakes and volcanic eruptions than almost anywhere else on Earth. We've discovered how the Earth builds mountains and why our planet is constantly moving beneath our feet. But building the land is only half the story. In Part 2, we'll explore how nature slowly carves, reshapes, and transforms those landscapes over millions of years, and why these processes still affect our lives today.